Finally, we will create a table to summarize our customer payment details, and this will be called Customer Payment Total, shortened to CUS Pay Total. Our initial brief from the Director Tom was to provide a summary of customer transactions in the California district. To start, we can identify what components we want to aggregate or summarize our data by. Let's start with the store address details, which is made up of the unique address ID, the address, and the district. As we know, the address ID is unique to the store ID, and details such as address and district are what we would refer to as supplemental or auxiliary details. We only need group on the address ID, and for address and district, we can maximize these fields. When grouping data in SQL, the more items we have in our group by statement, the more expensive our query will be to run. Identifying what items we can maximize, such as store address and store district, this will reduce our query runtime. Next, we can perform some data calculations on the payment date field. I will go ahead and extract the year from payment date and call this payment year, and also use the month function to extract the month from payment date and call this payment month. As we also want to group our data by payment year and payment month, I will place both values into our group by statement. Note that when placing such values in the group by, we don't want to have our aliases such as payment year and as payment month, as this will return an error if we try to run our code. There are a number of date functions supported by MySQL, and I would highly recommend once again to refer to the MySQL documentation for a full list of date functions. For now though, we will work with just the year and month functions, but if required, we could also extract details such as quarter, week, and day, if so required to produce a report at these levels. Knowing the level of aggregation that we will be performing, you should be able to calculate approximately how large the tables will be in size. For example, if we had 10 stores that we wanted to provide a monthly summary, then we would have 10 times 12 months producing 120 rows of data in total for any given year. If we wanted to include product details and we have 10 products, then this would increase our number of rows returned times 10, giving us 1,200 rows. So every time we add in a level of grouping or aggregation, you should also be attempting to calculate approximately how many rows of data this will return in your final result set. In large production environments, we may find multiple tables representing different levels of granularity for the business. For example, we might have a summary table of transactions at the monthly level, a separate summary table of transactions at a weekly level, and another one at a daily level. Moving on, we can now take a look at how to summarize our transaction details. To start, we will sum the amount and call this payment total. Next, we will perform a count on transaction ID and call this transaction count. And finally, we will perform a count distinct on our customer ID and call this customer count. Note that if we did not perform a distinct with our count customer ID, this would return the same value as our transaction count, which is also the same value as row count in our customer payment detail table, where this table is defined at the lowest level of granularity, that is, our customer transaction level. We can go ahead and run the select statement to view a summary of our customer transactions from the California district, as grouped by the corresponding store details. From here we can see that 2 stores have been identified. One store for 47 Mysacula Drive, and the other store with an address of 28 MySQL Boulevard. As noted, this is a sample or test set of transactions as created by MySQL and Oracle. So while we do not have a large number of rows of data being returned, the results will never change and makes for a very useful set of test sample data when reviewing new features in MySQL releases. Coming back to our analysis, you identify that there are no means to distinguish that the results we have obtained are for only customers in the California district. There are a number of options that we could take to bring in the details to show you that the dataset is representative of California customers. Option 1 will be to export our result set to a spreadsheet, and within our spreadsheet we can add a new column and present the values as being from California. While option 1 gets us our desired output, but ideally we want to update our SQL code to reflect the correct logic, as we may need to run this analysis again at a future stage, or wish to add this query into production. Option 2 will be to rerun our analysis and add in the appropriate customer district details at the beginning of our query. This would require that we rerun all our analysis and include the customer address details at the beginning of our analysis to be used in our final result summary. However, as we are working to a tight deadline of Monday morning, this may not be so simple if our analysis has taken a number of hours to run, where we might be dealing with very large transaction tables. Option 3. We can go back to our last step in our query and add in the appropriate customer and address table joins to pull back the customer district. And as we have done the majority of heavy analysis in steps 1 and 2, rerunning step 3 with some minor changes is not going to be costly to run. If we try to execute the create command with our new select statement, this will throw back an error saying that the table already exists. To recreate our table, I will first issue a drops table statement on our table sales customer payment total. Now I can go ahead and run the command to create a table with our newly modified select statement. If we had such a drop statement in production, where for some reason our table did not exist, if we try to drop a table that does not exist, this will return an error. To demonstrate, I will go ahead and first drop the table and then try rerunning our drop and create statement once again. To get around this error, we can use the if exists option with the drop table statement. The if exists will first perform a check for the table's existence, and if the table exists, the drop table will be performed. But if the table does not exist, MySQL will simply skip over the drop statement and move on to the next available statement, which is our create table as statement. In our results window, we can see that the drop statement, where the table did not exist, is now showing with a yellow triangle icon, which identifies that the statement ran but did not perform a drop table. A final option which I will show you, which is similar to option 1, with adding a field to a spreadsheet, is to add a new column to our table and manually update the required rows to reflect our value of California. First, I will revert our table and drop the new column, customer district, by using an alter table command as follows. Alter table sales customer payment total drop customer district. To add a new column to a table, I will issue an alter table command as follows. Alter table sales customer payment total add customer district varchar 20. I can refresh the sales database once again and check that our new column, customer district, has been added to the end of our table, customer payment total. I can go ahead and perform a select against our table and note that customer district is set to null. Next, I will perform an update statement as follows. Update sales, customer payment total, set customer district equal to California. I will go ahead and run a select against the table and can see that our customer district has been updated to the value of California. Note that a table update statement can be run in conjunction with a where clause, which I will now demonstrate. In this scenario, I will perform an update where payment months is equal to May and payment year is equal to 2005, and set the value of customer district to be Cal, an abbreviation for California. Once again, running a select statement against our table, we can see that the value has been updated to Cal. As with any update or delete statement, I would always encourage that you take a copy of your data into another table and perform your desired updates on a sample set of data to ensure that your update or delete statements are working correctly before applying them to a production table. As once you have updated or deleted an item in a table, there is no simple undo command in a database to roll back to a previous form of your data. If for some reason you have accidentally deleted or updated a field or number of rows incorrectly, you should contact your database administrator to attempt a rollback on the table, which will revert a table to a period prior to your updates, provided your database has rollbacks turned on. In most cases as a business or data analyst, you're not likely to be working with live production tables, and also not likely to have permissions to update such production tables. Therefore, in our case scenario, if we incorrectly updated one of our tables, we can simply drop or delete the contents of the table and repopulate with a given query. As you can see, there are a number of ways to update our analysis to get a desired output. In time, as you become more proficient with running queries, you will be able to weigh up which is the best option for you. As noted with our example above, if we are working to a tight deadline in our scenario, with producing a quick report, I would have likely to have chosen to just update the Excel spreadsheet manually and add in the appropriate code to our final query, but not actually run the query, as our results are easily added to a spreadsheet for California. However, if I was running this analysis for all states in America, I would then choose to run the final statement to correct the analysis and provide appropriate output for all states. That concludes this section on summarizing our customer payment details, and in the next section we will look at cleaning up our query to run in production, before finally moving on to produce a summary report of our data in Microsoft Excel and a dashboard of our results in Microsoft BI.